Alrighty, hello everybody. So this is your flipped homework talking about sample spaces. Now, the entire time we've been talking about probability, we've been talking about your possible outcomes. Well, it turns out that the possible outcomes have a very special name, and that's actually called the sample space. So the sample space describes all of the possible outcomes. So all of the possibilities of an event. The sample space can be, and we're going to use a fancy word here, displayed, aka represented, with lists, tables, and tree diagrams. Now, you don't know what those are right now, but you're going to know because I'm going to teach them to you. These things are used to find the probability of simple or compound events. Now, compound events are when like two or more things are happening. So like you're flipping a coin and you're spinning a spinner. You're choosing your pants and you're choosing your shirts. You're choosing what kind of cheese you want on your burger and what kind of bun you want on your burger. Simple probability would be like one spinner getting spun. What's the probability? Just to give you an idea of what the differences are. All right, so let's start out with number 1 here. It says the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? Whenever it's saying what are the possible outcomes, it's asking for the sample space. So the way that we represent this is we use a capital S. We say our sample space, S, fancy brackets. One option is that the Patriots win, comma. The other options is if the Cowboys win. So notice how we're laying out our sample space here. We have the S representing sample space, our fancy brackets, each option separated with a comma and closed fancy brackets. This is what your sample space will look like when you're talking more like a list. All right? Okay. A number cube is rolled. What are the possible outcomes? So remember, a number cube is just like the cube that we used in class yesterday. It's got a 1, 2, 3, 4, 5, and 6. Again, the proper way to write this would be an S for sample space, 2 dots, fancy brackets, which I am the absolute worst at. Then you have 1, 2, 3, 4, 5, 6. Now these two are considered simple events or simple probability because they just have one thing happening. Either the Patriots win or the Cowboys win. You're going to roll a cube. It's not saying, okay, what's the probability that the Patriots win, the Cowboys win, and it rains? See how we're talking about two different things there, but working at the same time? That's compound probability. That's just like what we'll see in example number 3, which says, for breakfast, Jamie can choose from cereal, eggs, or a muffin. So this is one situation. She can also drink coffee, orange juice, or milk. Another situation. What are all the possible outcomes? AKA, what is the sample space? And then how many total outcomes are possible? We're going to get to this at the end. So first, let's create our sample space. First, we'll create it as a list. The way that I like to do the list is I like to take my 3 options and start with one of them. Okay, so let's say we eat cereal. Well, what can we drink with our cereal? Well, we can drink coffee. Or we can have, cereal and OJ. Or we can have cereal and milk. Okay. That's 3 options right there. Well, what if we said, hey, we want to have eggs? So we've got eggs, and with our eggs we can have coffee. We can have eggs with OJ, and we can have eggs with milk. Okay, well, I got just one more option left. I've got a muffin. I can have a muffin with coffee. I can have a muffin with OJ, and I can have a muffin with milk. So now this is my list, and if I wanted to write it properly as a sample space, we would take it, put it inside of fancy brackets, and have S. on the side. Then you think, is this all my possible options? Well, yeah, you've got each one of your first one with each one of your second one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. There's another way that we could do this using a table. Let's go ahead and check that out. Now, you guys might not have enough room for that, but you might if you don't put it on another piece of paper. I just want to show you both to get you kind of, actually, let's keep it as a list. The next one we'll do as a table. Okay. Now, you know how we figured out that there's 9 possible outcomes here? 9 possible outcomes. Well, what do you notice we could have gotten that 9 from? Well, we had 3 for our first option, 3 for our second option. What can you do with the 2 3s to give you 9? Hopefully you say, oh, I could do 3 times 3 equals 9. You can do this every single time, and it's called the fundamental counting principle. This tells us how many possible outcomes. How many possible outcomes? Whereas the list shows us what the actual outcomes are, the fundamental counting principle tells us how many outcomes can we have. So if a question simply says how many outcomes, you don't have to sit there and make the whole list. You can simply multiply your options. Multiply how many of each option. Option by each other. Now throughout today I'll show you what that looks like as well as how to make our list and our table. Alright. For number 4, let's zoom in. It says at registration a student can select from Spanish or German class as well as art, music, or theater. What are all the possible outcomes, and how many total outcomes are there? Well, let's answer this question first because it's easier now that we know the fundamental counting principle. So, total possible outcomes. Total outcomes. Well, our first option, which is Spanish or German, only has 2, so that would be 2 times our second has 3. So 2 times 3 is 6. So 6 possible outcomes. Now we can make sure our table matches that. We did a list over here. We're going to do a table over here. So we're going to make a table like so. We're going to put our Spanish and German on the side. Spanish, German. Split the table in half, and across the top we'll put art, music, and theater. Okay, so let's split this up. All right. So now we're going to do this like we have areas. So we're going to look here and say, okay, this one, ooh, that's humongous. Let's make that smaller. For this one, we have Spanish and art. So this combination would be Spanish and art. This combination would have Spanish and music. So Spanish and music. This combo would have Spanish and theater. So Spanish and theater. Next, for our next row, I'll switch colors. For this one, we have German, and what is that? Art. So we have German and art. Our next block, we have German and music. So, German and music. Then we have German and theater. German and theater. Do you see how now we have Oh, what do we have? 1, 2, 3, 4, 5, 6 options. Now these 6 options are our sample space. What I circled is the sample space itself. Here is the possible outcomes, which is how many we have from a fundamental counting principle. Now here's a list, here's a table. Next we're going to talk about a tree diagram. I like the table and the tree diagram the best personally because I feel like it's a guaranteed way to make sure you have all your options. But that's up to you. Alrighty. So it says a fair coin is tossed twice. What are all the possible outcomes? How many total possible outcomes are there? So this one's asking for the sample space, like they want to see it, and how many total outcomes. We can use the fundamental counting principle. All right, well, let's talk about it. First of all, whenever we make a tree diagram, we always want to start. Now, we're going to branch off. When you flip a coin, you only have one of 2 options. Either you flip heads or you flip tails. So you have 2 options. You flip heads or you flip tails. Okay, so that's one toss. The first toss, either you flip heads or tails. So let's say you get heads on the first toss. Now you toss again. What are your options? Oh, you mean you can flip heads or tails again? You're right. You can flip heads or you can flip tails. Then same thing for the tails. Let's say you flip tails first. What are your next options? Well, it's a coin, so you can only get heads or tails again. So you have heads or tails. And this, my dears, is a tree diagram. You can show it this way. You can also show it horizontally by having your start at the top. Then you can branch off to heads and tails, and then both of those options will have a heads and tails option. Either way you like to look at it, it's up to you. Your choice. I like them both ways, but it doesn't much matter to me. So if you're talking this as a list, I'm going to get rid of this one so that I have space. Your options would be 4 total outcomes. 4 total outcomes. And to create our sample space, let's make it as a list. So first toss heads, second toss heads. Heads, heads. First toss heads, second toss tails. Heads, tails. First toss heads, second toss heads. Sorry, first toss tails, second toss heads. See how I'm tracking the tosses in a row? This is the first toss, this is the second toss, but they work together as a combo of an event. If this is confusing to you, don't worry, we're going to continue working on it. And then I have tails and tails. Now you might be able to think about this sample space on your own without drawing the tree diagram because it is a smaller compound event. And that's fine. So you have heads, 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 tails, tails, heads, heads, tails, tails. So these are all different ways that you could represent it. You could have also created a table. And if you were going to create a table, it would look like this. You'd have tails, heads for the first toss, tails, heads for the second toss. Then you have TT, TH, HH, and then HT. So these are the 3 different ways you could represent. You have a list table, tree diagram, all that jazz. Now, if you're feeling like, okay, I kind of get this, go ahead and give these a try. If you're not confident, hang tight with me and we'll do them together. All right. Amanda will roll a number cube and flip a coin. If Amanda rolls a number cube once and flips the coin once, then what are the possible outcomes in which the number cube lands on an odd number? Okay, well, the number cube landing on an odd number has a sample space of 1, 3, 5. Then the coin landing on heads or tails has a sample space of heads or tails. Those are the options. Now, when we do this as a compound event, that means they're happening at the same time. So that means my new full sample space means I could roll a 1 and flip a heads. But I can also roll a 1 and flip a tails. I can roll a 3, flip a heads. Roll a 3, flip a tails. I can roll a 5, flip a heads. Roll a 5, flip a tails. And that covers your entire sample space. All those options. If you wanted to represent this as a table, you would have, I'll put heads and tails. I don't like that actually. Let's do longer, around, make it 1, 3, 5. Heads, tails. So we get 1H, 1T, 3H, 3T, 5H, 5T. See how you get the same sample space, just in a different organized manner? All right. So we have 1, 2, 3, 4, 5, 6. You can double check to make sure you have all the outcomes by using the fundamental counting principle. By saying, okay, we have 3 options, so 3 times 2 options 2 is 6 total outcomes. So you made it. You did it correct. Nicely done. All right, number 7. The 2 spinners below are spun at the same time. What are the possible outcomes of the 2 spins? Well, first of all, we know that we have 2 options, then 4 options. So the fundamental counting principle tells us we should have 2 times 4, so we should have 8 total outcomes. Let's see if we can list them. I'm going to do this one as a list using a sample space with fancy brackets. So I can spin a 1 and spin yellow. I can spin a 1, I can spin blue. I can spin a 1, I can spin red. I can spin a 1, I can spin orange. All right. Then I can spin a 2 and I can hit yellow. Whoops. I can hit a 2, I could hit blue. I could hit a 2, I could hit red. I could hit a 2, I could hit orange.
Dismissal wave 1, I now exit the building.
Fancy brackets.
You came in. Dismissal wave 1.
All right.
Also,
This is a list.
In acting, there is an information.
This is a tree diagram. Uh-oh, tree diagrams. We're going to use the information to answer the question. A clothing line has shirts in red, blue, or white, and pants in gray or khaki. All right, so we're talking about shirts, and there's 3 options, red, blue, or white, and pants that are gray or khaki. How many different combinations can be made with the clothing line? Now they specifically say to use a tree diagram, so we have our start. Then if you want to start with the shirts, you can. Start with the pants, you can. Honestly, it doesn't matter which one you start with. I'm going to start with the shirts because it comes first. So we have a possibility of red shirts. We have a possibility of blue shirts. And we have a possibility, of white shirts. Now, if you choose the red shirt, you still have 2 pants opportunities. You can still wear the gray or the khaki. Same for the blue. Gray or khaki. Oh, that's ugly. Switch that. Gray or khaki. Gray or khaki. Our total outcomes are here. So we have 1, 2, 3, 4, 5, 6 total outcomes. 6 total outcomes.
Dismissal wave 2 may now exit the building for the door you came in. Dismissal wave 2.
And the sample space as a list would be RG, RK, BG, BK, WG, WK. All right. Okay, when buying a car, Esther can choose a 2-door or a 4-door, or a car in black, silver, or white. How many different combinations can be made with a tree diagram? So we have our start. Then we could choose a 2-door or a 4-door. Then from here we can choose either black, silver, or white. Then from here we choose black, silver, or white. So we have 1, 2, 3, 4, 5, 6 possible outcomes. And the sample space as a list would be 2-door black, 2-door silver, 2-door white, 4-door black, 4-door silver, 4-door white. Last but not least, Sergio tossed a 2-sided red and yellow counter chip. So we're just talking about 2 options. It's like flipping a coin, heads or tails, but this one's red or yellow. Create a tree diagram to represent all the possible outcomes to the coin landing on red or yellow if he tossed it twice. All right, well, let's decide. Sergio starts, and then the first toss, he can either get red or yellow. That's the first toss. But then the second toss, if he got red the first time, well, he can get red or yellow again. And same if he got yellow, he can get red or yellow again. So that's the second toss. So there's 4 possible outcomes. And as a list, it would be red, 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 yellow, yellow, red, yellow, yellow. Done. All right, guys, summarize today's lesson, and we'll practice tomorrow in class. Thank you so much. See you later.